Yeah, hello students. Good evening to one and all. And now let us going to discuss partial fractions as well as random variables. First, let us see what are partial fractions. Yes, this is partial fractions topic. Right, partial fractions, rational fraction. If f of x and g of x are two polynomials and g of x is a non-zero polynomial, then f of x divided by g of x is called a rational fraction. Understood? Rational fraction. If f of x and g of x are two polynomials and g of x is a non-zero polynomial, then f of x divided by g of x is called rational fraction. Next, proper and improper fractions. This is already known to us. A fraction f of x over d of x is called proper fraction if the degree of f of x is less than the degree of g of x. If the degree of f of x is less than the degree of g of x, then what do we call it? Proper fraction. Otherwise it is called an improper fraction. Otherwise it is called an improper fraction. Okay, let us see the rules now. Rule number 1. Let f of x divided by g of x. Let f of x divided by g of x be a proper fraction to each non-repeated factor ax plus b of g of x. There will be a partial fraction of the form a divided by ax plus b, where a is a non-zero real number to be determined, and let f of x divided by g of x be a proper fraction to each non-repeated factor of ax plus b whole power n, where n is a positive integer of g of x. There will partial fraction of the form. Okay, there will be a partial fraction of the form a divided by, means here a1, repeated factors are there, right? a1 divided by ax plus b and a2 divided by ax plus b whole square plus a3 divided by ax plus b whole cube plus and so on, plus an divided by ax plus b whole power n, where a1, a2, a3 and so on, an are to be determined constants. Okay. Rule number 3. Let f of x divided by g of x be a proper fraction. To each non-repeated quadratic factor ax square plus bx plus c of g of x, there will be a partial fraction of the form ax plus b divided by ax square plus bx plus c, where a comma b belongs to R. Let f of x divided by g of x be a proper fraction. If n greater than 1 belongs to n, is the largest exponent, so that ax square plus bx plus c whole power n, where a not equal to 0 is a factor of g of x, then corresponding to each such factor, there will be a partial fractions of the form a1x plus b1 divided by ax square plus bx plus c, a2x plus b2 divided by ax square plus bx plus c whole square, plus and so on, plus anx plus bn divided by ax square plus bxc whole power n, where a1, a2, a3 and so on an, b1, b2, b3 and so on bn are to be determined. Okay, these four rules are about proper fractions. If f of x divided by g of x is an improper fraction with the degree f of x greater than degree of g of x, then by using division algorithm, f of x over g of x can be written as q of x plus r of x divided by g of x, where g of x is not equal to 0, r of x divided by g of x is a proper fraction. Further, r of x divided by g of x can be solved into partial fraction using the above four rules. Okay, then let us see the short answer type questions from this chapter, what we are going to expect in the examination. Resolve 5x plus 1 divided by x plus 2 times x minus 1 into partial fractions. So here 5x plus 1 divided by x plus 2 times x minus 1, which is equals to a divided by x plus 2 and plus b divided by x minus 1, where a and b are non-zero real numbers to be determined. Then 5x plus 1 divided by x plus 2 times x minus 1. How do we write this? Here the degree of denominator is 2 and the degree of numerator is 1. So we are splitting like a divided by x plus 2 and plus b divided by x minus 1. So take the LCM first. Then denominator gets cancelled. Then numerator is equal to the numerator is a of x minus 1 plus b of x plus 2 is equals to 5x plus 1. Then by putting x equal to 1 into equation number 1, so that in two ways we can do here, by plugging x values, okay, by taking x equal to something, or else by comparison we can do it. Okay, in two different ways we can do this. Next, question number 2. Resolve 2x plus 3 divided by x plus 1 times x minus 3 into partial fractions. This is also same like question number 1 only. So here a by x plus 1 plus b by x minus 3. We are taking LCM. Okay, we can take LCM. Better do in the first way only, sir. If you do it like the first way, what do we get here? A times x minus 3 plus b times x plus 1 we can get. This is equals to 2x plus 3. Then we can get ax minus 3a plus bx plus b, which is equals to 2x plus 3. So a plus b of x minus 3a plus b, which is equals to 2x plus 3, where a plus b is 2, minus 3a plus b is 3. Solve these two, then also you can get a and b values. Okay, if you are getting a doubt with why to substitute x values, we can do like this also. Or else by taking x equal to 0 or x equal to 1, then also we can get it. And here in question number 3 you see, resolve x square plus 5x plus 7 divided by x minus 3 whole cube into partial fractions. So here what we have to do, x square plus 5x plus 7 divided by x minus 3 whole cube, which is equals to a divided by x minus 3 plus b divided by x minus 3 whole square plus c divided by x minus 3 whole cube. Okay, let a, b and c are consonants to be determined. Again we can take the LCM in the same way. What we are getting here, a times x minus 3 whole square plus b times x minus 3 plus c times plus c divided by x minus 3 whole cube. Both the sides x minus 3 whole cube gets cancelled. This is equals to x square plus 5x plus 7. X square coefficient. What is x square coefficient? Is only a. Here x square coefficient is 1. Next x coefficients 2a plus b, which is equals to 5. Already a is 1. 2 plus b is equals to 5. Then b is equals to 5 minus 2, which is 3. Next to constants you compare so that you can get c value. Okay. Right, a equal to 1, b equal to 11, b equal to x coefficient is 5 that side. This side, out of the x coefficient is 2a. Only 2a plus b. A value already we got 1. Oh, this is a x minus 3 whole square. 6 here. 6. Then also we can get 5 minus 6, right? Minus what? Acha, minus 2 will come. Okay, I'm sorry. 5 plus 6 is 11. Okay. Okay, Hanan. Okay. Next question number 4. X square plus 13x plus 15 divided by 2x plus 3 times x plus 3 whole square into partial fractions. You see here in the denominator we have 3 factors, 2x plus 3, x plus 3 and x plus 3 whole square. Totally 3 factors we have. Then we can split the fraction into 3 fractions, which is a divided by 2x plus 3 plus b divided by x plus 3 plus c divided by x plus 3 whole square. So if we take the LCM, a times, here what is the LCM? 2x plus 3 times x plus 3 whole square. So we can get a times x plus 3 whole square plus b times 2x plus 3 times x plus 3 and plus c times 2x plus 3. By the denominator, both the denominators are cancelled, then we can get which is equals to x square plus 13x plus 15. First comparison of x square terms. Here the coefficient of x square is 1, here the coefficient of x square is a, so a is 1. The value of a is 1. Yes or no? Am I correct or not? The value of a is 1. And you see a times x plus 3 whole square. We can write sir one more step by confusion. A times x square plus 6x plus 9 plus b times here 2x times x, 2x square and 2x times 3, 6x plus 3 times 3, 9 plus c times 2x plus 3. Now all the powers are expanded, which is equals to x square plus 13x plus 15. Now write, so a of x square plus 6x plus 9, here x square coefficient is a, here x square coefficient is 2b, so a plus 2b, which is equals to 1, right? This is equation number 1. Next to x coefficients, here 6a is the x coefficient and whereas 6b is the x coefficient, and here it is c times 2x plus 3, so plus 2c, which is equals to 13. This is second equation. And then constants 9a plus 9b, okay, 9b plus 3c, which is equals to 15. This is nothing but 3a plus 3b plus c, which is equals to 5. And here it is This can be written as 3a plus 3b. Yes or no? 3a plus 3b 2x, 2x times x, 2x squared, 2x times 3, 6x, 3 times x, this is 9x. My god, 3 3s are 9. So here x coefficients where we compared, here we compared. Then this is no change here. Then as it is. Yeah, now we have to solve these equations. 6a 2a plus 2b is equals to 1, 6a plus 9b plus 2c is equals to 13, 3a plus 3b plus c is equals to 15. Totally 3 equations we have. Right? Now you can understand what is the need of taking x values and substituting. In this case, you see here substitution will become difficult. Means solving will become difficult. We have 3 different equations. Here we have 3 different equations. We have to solve them. Yes or no? We have to solve them, and that two equations are there in 3 variables, and only one equation is there in 2 variables. So in this situation, especially for this kind of question, we can take the help of placing x values. We can take the help of placing x values. That will help us to get at least one value. At least one value of a or b or c. If you get at least one value of a or b or c, then easily we can take what do I say? Then easily we can get the remaining values. Right? So what we have to do? Either solving these 3 equations, or else we have to take either x is equals to 1 or x is equals to 2 or x is equals to minus 1, like that any one of value of x, so that to get at least one variable, so that at least one constant value, at least a value if we get, based on a value from the first equation b value we get, then if we substitute a and b into the second or third equation, we can get a c value. Okay. Next one, question number 5. X plus 4 divided by x square minus 4 times x plus 1 into partial fractions. So x square minus 4 can be split into x minus 2 times x plus 2. Then we can write this as a over x plus 1 plus b over x plus 2 plus c over x minus 2. As usually, take the LCM. As usually, you can take the LCM. Then what you get? You get after taking LCM and cancellizing the denominators, you will get x plus 4, which is equals to a times x plus 2 times x minus 2 plus b times x plus 1 times x minus 2 plus c times x plus 1 times x plus 2. Now we need here only 2 variables, 3 variables are there. So in any way, by placing x equal to something, or else by comparison also you can get it. So here suppose if you want to simplify further, then here what do we get? X plus 2 times x minus 2 is x square minus 4, and plus b times x plus 1 times x minus 2, that is x square minus 2x plus x minus 2, plus c times x square plus 3x plus 2. So here taking the coefficients, x square coefficients is a, b and c. So we can get a plus b plus c is equals to 0. And then x coefficient is minus b, here plus 3c, minus b plus 3c, which is equals to 1. Okay, and next constants, here minus 4a, here minus 2b, here plus 2c, minus 4a minus 2b plus 2c, which is equals to, we can solve these 3, or else we can place x is equals to any value. Right? Here x plus 2 is there, x minus 2 is there, x plus 1 x minus 2, x plus 1 x plus 2. So if we want to eliminate b and c, what is the common factor in b and c? X plus 1 is common factor in b and c. So let us take x is equals to minus 1. If you take x is equals to minus 1, b and c constants will be cancelled. Only a constant will be left here. A times minus 1 plus 2 minus 1 minus 2. Minus 1 plus 2 is 1, and minus 1 minus 2 is minus 3. 1 times minus 3 is minus 3. Minus 3a is equals to minus 3. Then you can get a value. Minus a is equals to minus 1 plus 4, 3. This is minus 3. So a is equals to minus 1 you are getting. Right? In a similar way, if you want to eliminate a and c, in a and c what is the common factor? X plus 2 is the common factor. So put x is equals to 2. If we place x is equals to minus 2, then a gets cancelled, and here c terms also gets cancelled. Only the middle b terms will be left. Then minus 2 plus 1 minus 1, minus 2 minus 2 minus 4, minus 4 minus 1 is 4. 4 is equals to minus 2 plus 4. 4b is equals to minus 2 plus 4 is plus 2. Then b is equals to 1 over 2. Okay, next c value. C value also similar. In a and b, what is common? X minus 2 is common. So place x is equals to 2. If you substitute x is equals to 2, then we can get a c value also. Next, question number 6. Resolve x square minus 3 divided by x plus 2 times x square plus 1 into partial fractions. So here x square minus 3 divided by x plus 2 times x square plus 1. So the degree of the denominator is 3, degree of the numerator is 2, so it is still proper partial fraction. Then this proper partial fraction can be written into a over x plus 2 times plus here what do we say, this factorization, factoring into linear factors is not possible for x square plus 1. X square plus 1. That is the reason what we are taking there, bx plus c we are taking. Alright, it is one of the rules in the above rules, right? So x square minus 3 is equals to a times x square plus 1 plus bx plus c times x plus 2. So let us substitute x is equals to minus 2 so that b and c terms gets cancelled. We get 4 plus 1, 5a is equals to 4 minus 3, 1. 5a is equals to 1, then a could be equal to 1 over 5. Next, what we have to get, we need to calculate b and c values next. B and c values, so to get b and c values, what we are doing here, we are comparing x square coefficients, because x square coefficients are a and b. A plus b is equals to 1. Already a is known as 1 over 5. Then we can get b is equals to 1 minus 1 over 5, that is 4 over 5. Then by comparing x terms, or else what do I say, comparing constants also, we can get the value of c. If we suppose, if you are comparing the constants, constant is minus 3 and that side a is there, and here the constant is a 2c. If you want to suppose compare x coefficients, what are the x coefficients? 2b and c. 2b plus c is equals to 0 and c is equals to minus 2b. Already we have known b is 4 over 5. Then c will become minus 8 over 5. Right, next question number 7. Resolve 2x square plus 1 divided by x cube minus 1 into partial fractions. So 2x square plus 1 divided by x cube minus 1, proper only. But x cube minus 1 factorization is not possible completely, but we have a chance to write it as x minus 1 times x square plus x plus 1. Okay. So x minus 1 times x square plus x plus 1 can be split into x minus 1 times x square plus x plus 1. Then if we write the partial fractions, we can get a divided by x minus 1. Then it is x square plus x plus 1, x square plus x plus 1, as its factorization is not possible. Then we can write it as bx plus c divided by x square plus x plus 1. Now as usually take the LCM, denominators will be gets cancelled. 2x square is equals to ax square plus x plus 1 plus bx plus c times x minus 1. Either by comparison, or else you can take by substituting x is equals to 0 or x is equals to 1. From that also we can get the values of, what do we get? The values of constants a, b and c. Right? Okay, same model I am not solving here. Right, let us come to the question number 8, different model here. 3x to the power of 3 minus 2x square minus 1 whole divided by x to the power of 4 plus x square plus 1. So here 3x to the power of 3 minus 2x square minus 1, and the denominator is x to the power of 4 plus x square plus 1. Degree of the denominator is more than the degree of the numerator, so it is a proper fraction still. But x power 4 plus x square plus 1 can be written as x square plus 1 whole square minus x square. That is nothing but x square plus x plus 1 times x square minus x plus 1. So we can write them as a product of two quadratic factors, x square plus x plus 1 into x square minus x plus 1. And further factorization is not possible, so that we can split the fraction as ax plus b divided by x square plus x plus 1 and plus cx plus d divided by x square minus x plus 1. So that we can get ax plus b times x square minus x plus 1 and cx plus d times x square plus x plus 1. And by comparing the coefficients of x cube, x square and x, so that here x cube coefficients are ax times x square a will come and cx times x square c will come, a plus c we can get. And then if we compare the x square coefficients, minus ax square will come, bx square will come, minus a plus b, and here cx square plus c and dx square plus d. So finally what we are getting, minus a plus b plus c plus d is equals to minus 2. Okay, now let us see any other way to get the values easily. If you substitute x is equals to 0 and we get a and c gets cancelled, but here 1 will be, here also 1 will be, or if we let us take 1 x is equals to 1, it is becoming lengthy, so that we can compare the constants also. Then b plus d is equals to minus 1, a plus c value we have and b plus d value also we have. Then from equation number 2, a plus c is equals to 3, from that c is equals to 3 minus a. And then from equation number 5, b is equals to minus 1 minus b. Then place these two values into equation number 3, so that it will be converted in terms of a and b. And here plus b already there, we are substituting minus b in the form of minus 1 minus b. Plus b and minus b gets cancelled, so that we can get a value easily. What is that a value? 2 here. Understood here what they done? We have a plus c is equals to 3 here. From this we can get c is equals to 3 minus a. And here we have b plus d is equals to minus 1. From this we can get d is equals to minus 1 minus b. Already we have minus a plus b plus c plus d equal to minus 2. Substitute the values here, a minus a only, plus b only, plus c, that is plus 3 minus a, plus d minus 1 minus b equal to minus 2. Minus b gets cancelled. Minus a minus 2a plus 3 minus 1 minus 4 equal to minus 2. So we are getting a is equals to plus 3 minus 1, plus 3 minus 1 is plus 2. Okay, so a is equals to 2 we are getting. Now if we substitute this a value into the first equation, we can get c value. If we substitute c value also we got now. A value, c value we got. If you substitute a value, c value into either 3 or 4, what do we get? We can get b value also from 4. From 4 we are getting b value. Okay, a equal to 2 substitute here. A equal to 2 substitute, and c can be written in terms of a, and d also can be written in terms of b. Then we are getting b value. So all the values we have. Question number 9. Resolve x to the power of 4 divided by x minus 1 times x minus 3 into partial fractions. X to the power of 4 divided by x minus 1 into x minus 2. So here the degree of the numerator is 4 and the degree of the denominator is 2. It is not proper. The given fraction is not proper. The given fraction is not proper. So given fraction can be improper fraction can be converted into proper fraction. So what we have to do further, we have to divide x to the power of 4 with x square minus 3x plus 2. We have to divide this x to the power of 4 with x square minus 3x plus 2. So that what you get here, x power 4 is there, here x square is there, so we require x square here. X to the power of 4 minus 3x cube plus 2x square, then minus plus minus, these two gets cancelled. 3x to the power of 3 minus 2x square. Okay, now 3x cube is there, so here minus 3x is required plus 3x. 3x times x square is a 3x cube, and 3x times 3x is minus 9x square plus 6x plus minus, these two gets cancelled, and here it is 7x square minus 6x. Okay, 7x square minus 6x and 7x square plus 7, we can take 7x square minus 21x plus 14. Then subtract, these two gets cancelled. This will be 15x and minus 14. So 15x minus 14. If we use the division rule, dividend is equals to x power 4 is equals to divisor. Okay, dividend is equals to divisor plus quotient. So like that we can write now. Or else, what do we write here? We can write improper fraction. Improper fraction can be written as what? X square plus 3x plus 7 plus 15x minus 4 divided by minus 14 divided by x square minus 3x plus 2. This is also divided into quotient plus 2. Okay, right. And then now the process is as usual. What is the process here? 15x minus 14 divided by x square minus 3x plus 2 is there. So 15x minus 14 divided by x square minus 3x plus 2. X square minus 3x plus 2 is nothing but x minus 1 into x minus 2. So let us write the proper fractions for this as a by x minus 1 plus b by x minus 2. Take the LCM and place x is equals to 1 to get a value and put x is equals to 2 to get a b value. So after getting a values and b values, the fractions will be like 1 by x minus 1 and 16 by x minus 2. Minus 1 by x minus 1 plus 16 by x minus 2, because a value is negative 1 and b value is 16. As usually x square plus 3x plus 7. Right? Next, question number 10. What is this? Question number 10. Resolve x to the power of 3 divided by x minus a into x minus b into x minus c. Both are having equal degree. Both are having equal degree. Still, it is improper fraction. So this kind of fractions can be written as 1 plus a by x minus a plus b by x minus b plus c by x minus c. Then if you take the LCM, x minus a, x minus b, x minus c plus a by a times x minus b, x minus c plus b times x minus a, x minus c plus c times x minus a, x minus b. Solving is very easy. If you place x is equals to a, you can get a value. If you place x is equals to b, small b, then you can get capital B value. And if you place x is equals to c, then you can get capital C value. That's what they done here. X is equals to a, x is equals to b, x is equals to c. So capital A, capital B, capital C. To get capital A, x is equals to small a, we have to substitute. To get capital B, x is equals to small b, we have to substitute. To get capital C, x is equals to small c, we have to substitute. Next one is a problems for practice. So 5x plus 6 by 2 plus x into 1 minus x. So how do we do this? We can do it as a divided by 2 plus x plus b divided by 1 minus x, taking LCM and simplification. Next, question number 2. 2x plus 3 by x minus 1 whole cube. This is what a by x minus 1 plus b by x minus 1 whole square plus c by x minus 1 whole. Okay. Next, question number 3. X square minus 2x plus 6. X square minus 2x plus 6. This is also same set. A by x square minus 2x plus 6. If any factorization is possible, then factorize it, or else do it directly. X square minus 2x, sum is minus 2 and the product is 6. 2 3 is 6. No, directly now. And the next one is number 4. Resolve 1 over x minus 1 whole square times x minus 2. A by x minus 1 plus b by x minus 1 whole square plus c by x minus 2. Next, resolve 9 by x minus 1 into x plus 2 whole square. A by x minus 1 plus b by x plus 2 plus c by x plus 2 whole square. Next, question number 6. 2x square plus 3x plus 4 and x minus 1 into x square plus 2. Still linear only. But x minus 1 is okay. A by x minus 1, x square plus 2 we cannot further factorize. It is not a linear factor, so that we can get to x minus 1 divided by x square plus 2. That means ax plus b. This is we can write like this: a by x minus 1 plus bx plus c divided by x square plus 2. Next, x square divided by x minus 1 times x minus 2 into partial fractions. It is like that x minus a, x minus b, x minus c quotients are both are having same degree, then we can write 1 plus a by x minus 1 plus b by x minus 2. That's about partial fractions topic. Right? What is our next topic? Today's next topic, random variables. Okay, let us see random variables. There is small chapters are random variables. It is like major topic in still we can call here. Yes. Random variables and probability distribution. Chapter number 10. So random variables. Suppose S is a sample space of random experiment, then any function x from S to R is called random variable. What they are saying, a random variable. Suppose S is a sample space of random experiment, then any function x from S to R is called random variable. X from S to R is called a random variable. Probability distribution function. Let S be a sample space and x from S to R be a random variable. The function f from R to R denoted by f of x is equals to p, where x less than or equals to x is called probability distribution function of the random variable x. Understood this one? Probability distribution function. Let S be a sample space and x from S to R be a random variable. Okay, x is a random variable. Then we are defining a function from R to R. How the function will be? The function is in terms of x, that is equals to p. Function is in terms of x, that is equals to p, and where x is capital X is less than or equals to small x. Now discrete random variable. A random variable x whose range is either finite or countably infinite is called a discrete random variable. If the range of x is x1, x2, and so on xn, or else it is infinite function, then x is called a discrete random variable. Okay, a random variable x whose range is either finite or infinite, either finite or countably infinite is called discrete random variable. Then the range of x. Next, x from S to R is a discrete random variable with a range infinite set. Then p of x is equals to xi greater than or equal to 0 for every I. Summation I greater than or equal to 1, p of x is equals to xi is 1, and here the formula for mean is given and variance is given. Mean is summation xi times P of x is equals to xi, and variance is sigma square is equals to, variance is yes, variance is, variance formula is what? Summation xi square times x minus xi minus mu I square, minus mu I square. Okay, what is mu here? Mu is mean. Right, let us see the binomial distribution. P of x is equals to x, that is equals to ncx p for x into q for n minus x, and where x belongs to 0, 1, 2 and so on. N and p are called parameters exactly of the binomial distribution, and mean binomial distribution is np, and variance of the binomial distribution is npq. npq. Right. Next to Poisson distribution, x is equals to p of x is equals to x e power minus lambda into lambda power x whole divided by x factorial, where x is equal, where x belongs to 0, 1, 2 and so on, and lambda is greater than 0. Let us see the questions. Try to learn the all formulas perfectly. Right. So the mean and variance of a binomial variable x are 2.4 and 1.44 binomial variables. So NP and NPQ is given, NP is 2.4 and NPQ is 1.44. Then we can get from these two, Q is equals to 0.6. Find the value of P. They are asking P plus Q is equals to 1 here. P plus Q is equals to 1. So that Q already there, then P is equals to 0.4. Then substituting P is equals to 0.4. In first equation, so that we can get n, and they're asking P of 1 less than equals to x less than equals to 4, that is P of x is equals to 2 plus P of x is equals to 3 plus P of x is equals to 4 according to binomial distribution formula. 6 equal to 2 power 4 p square, 6 equal to p cube, 6 equal to square p power 4. Then if we substitute p value, q value and simplify, then we can get 2268 divided by 3125. Right? Direct formulas and direct formulas. In this chapter, all the problems are almost related to formulas or direct formulas. Next one is a Poisson variable satisfies P of x is equals to 1 is equals to P of x is equals to 2, find P of x is equals to 5. So Poisson variable formula, I don't know what is Poisson variable formula. E to the power of minus lambda into lambda power x divided by x factorial. Okay, x is equals to 1 is given. Substitute x is equals to 1, P of x is equals to 1. What is P of x is equals to 1? E power minus lambda into lambda power 1. E power minus lambda into lambda power 1 divided by x factorial, that is 1 factorial. And x is equals to 2, e power minus lambda into lambda power 2 whole divided by 2 factorial. These two must be same. E power minus lambda gets cancelled. Lambda power 1, lambda power 2 will become lambda. 1 factorial, 2 factorial will become 2. So we are getting, what we are getting, 2 lambda is equals to lambda. What we are getting, lambda is either 0 or lambda is 2 we are getting. So we can continue with lambda is equals to 2, right, because lambda is greater than 0. Then they are asking what is P of x is equals to 5. E power minus 2, in the formula substitute the values. E power minus 2 and 2 to the power of 5 whole divided by 5. Okay, now let us see the next question. So, what is the next? I have completed my charger. So, what is the next question here? In a book of 450 pages, there are 400 typographical errors. Assuming the number of errors per page, follow the Poisson law. Find the probability that the random sample of 5 pages will contain no typographical error. The average numbers of errors per page in the book 400 divided by 450. Because 450 pages are there and 400 typographical errors are there in the page. No, finally, it means all the errors. So total errors divided by 450. What we are getting 8 over 9. And in the probability that there are x errors per page. So Poisson formula, if we write e power minus lambda into lambda power x by x factorial, and e power minus lambda substituted, then we are getting to get no errors, but x is equals to 0, so that e power minus 9 minus 8 by 9. Required probability that the random sample of 5 pages will contain no errors. So 5 pages do not have any error, then p of x equals to 0 whole to the power of 5. Question number 4, find the minimum number of times of a fair coin must be tossed so that the probability of getting at least one head is at least 0.8. So minimum number of times a fair coin must be tossed. What is the probability of getting at least one head? It is a 0.1 head. It is at least 0.8. So we are taking minimum number of times the fair coin tossed is n, and x denotes the number of hits getting. Then x follows the binomial distribution with parameters n and p. P of x greater than or equal to 1 is greater than or equal to 0.8, because 0.8, at least 0.8 they said, that is the reason we are writing x greater than P of x greater than or equal to 1 is greater than or equal to 0.8, that is given. And P of x greater than or equal to 1 is nothing but 1 minus P of x is equals to 0. So finally P of x equal to 0 is less than or equals to 0.2. P of x equal to 0 formula write down and substitute the value of p is getting it. Then 2 for n is greater than or equal to 5, then it is 2 for n greater than or equal to 3. So for n is equals to 3 or more, it is 2. The minimum value is 3. Next, question number 5. 8 coins are tossed simultaneously. Find the probability of getting at least 6 heads. 8 coins are tossed simultaneously. Find the probability of getting at least 6 heads. The probability of getting a head is 1 by 2. The probability of getting a tail is 1 by 2. Probability of getting r heads in a random throw is 8 coins. 8 coins are tossed simultaneously. Okay, so p of x is equals to x is nothing but 8cx times half whole power x, half whole power 8 minus x. Because n is 8 number of times throwing, and 8cx into half whole to the power of 8, x is equals to 0, 1 to 8. So probability of getting at least 6 heads, x must be greater than or equal to 6. So p of x equal to 6, x equal to 7, x equal to 8. Substitute the formula, write the formula and substitute the values. So 8c6 1 by 2 whole power 8, 8c7 1 by 2 whole power 8, 8c8 1 by 2 whole power 8. Okay, because p and q values are same, that is the reason we are getting that 1 by 2, always 8. Then we can get 37 divided by 256, right? And the next question, once in 9 ships is likely to be wrecked when they are set on sail. When 6 ships are on sail, find the probability for at least 1 will arrive safely, exactly 3 will arrive safely. Given 1 in 9 ships to be wrecked. 1 in 9 ships to be wrecked. So probability of ship to be wrecked is 1 over 9. But p of plus q is equals to 1, p is equals to 1 over 9, then q is equals to 8 over 9. P and q values we got. Number of ships, n is equals to 6. When 6 ships are in sail, so n is equals to 6. P of x equal to 0 for 5. If you write nc 0 into p to the power of n minus 0 into q to the power of 0. So n is 6, p is 6, n is 6, p is 1 over 9, q is 8 over 9. Then probability of at least 1 will arrive safely. At least 1 will arrive safely. At least 1 will arrive safely. So greater than or equal to 0. 1 minus p of x equal to 0. Simplified. Second bit is exactly 3 will arrive safely. Exactly 3 will arrive safely means p of x is equal to 3 we have to find out. P of x is equal to 3 we have to find out. Right? Next, long answer type questions. A cubical die is thrown. Find the mean and variance of x, giving the number on the face that shows up. Giving the number on the face that shows up. Let S be the sample space and x be a random variable associated with S, where p of x is given by the following table. X is equals to xi. So if x is equals to 1, we are getting 1 over 6, then 2, 1 over 6, for 3 also 1 over 6, for 4 also 1 over 6, up to 6 it is 1 over 6 only. Mean of x is mu is equals to summation I is equals to 1 to 6 xi times p of x is equals to xi. Substitute everything into the formula, we can get the value. And then variance formula is summation x is equals to 1 to 6 xi square into p of x is equals to xi minus mu square. Mu already known 7 by 2 and xi square times p of x is equals to xi also calculate. Xi is 1 now. Yeah, for 1 it is, for 2 it is. Continue. Next question number 2. The probability distribution of a random variable of x is given below. Table is given already. Find the value of k, mean variance of x. So summation I is equals to 1 to 5 p of x is equals to xi is 1. Then what we are getting, 1 over 15, k equal to 1 over 15 we are getting. Then mean mu is equals to summation I is equals to 1 to 5 xi times p of x is equals to xi. Substitute everything. 1 times k, 2 times 2k, 3 times 3k, 4 times 4k and so on, 5 times 5k. Next variance, already mu square we have 11 by 3 whole cube, 11 by 3 whole square, and remaining calculate 1 square into k, 2 square into 2k, 3 square into 3k, 4 square into 4k, 5 square into 5k. Simplify and substitute k value. Next question number 3. Find the constant c so that f of x is equals to c times 2 by 3 whole power x, where x is equals to 1, 2, 3 and so on, is the PDF of a discrete random variable x. So f of x is given c into 2 by 3 whole power x. If we substitute x is equals to 1, then f of 1, f of 2, f of 3 and so on we can get. What they are saying here, summation f of x is equals to c times summation 2 over 3 whole to the power of x is equals to 1. So we don't know c here, discrete random variable. So it is infinite GP and R value is 2 over 3 which is less than 1. A by 1 minus that formula we can apply, then we can get c is equals to 1 by. Clear? Next, let x be a random variable such that p of x is equals to minus 2, p of x is equals to minus 1, p of x is equals to 2, p of x is equals to 1. All are equal to 1 over 6. And p of x equal to 0 is 1 over 3. Find the mean variance of x. Find the mean and variance of x. Mean is mu is equals to summation k minus 2 to 2 xi times p of x is equals to k. Then mean will become 0. And variance x is equals to k. Right like this. Variance is equals to summation k equal to minus 2 to 2 k minus mu whole square into p of x is equals to k. Generally we can write xi square that formula. Okay, then we are getting 5 over 3 here. Then the next question is a random variable x. A random variable x has the following probability distribution. X is equals to xi and p of x is equals to xi. So 0 to 7 and their probabilities are 0k, 2k, 2k, 3k, k square, 2k square, 7k square plus k. Then what they are asking, find k first one. So equal to 1 we can take and we can find out k. Then mean formula we can apply, 0 less than x less than 5. So let us take first sum. P of x is equals to 0, P of x is equals to 1, P of x is equals to 2 and so on, P of x is equals to 7 is equals to 1. So that k is equals to 1 over 10. And the next second one is mean. Mean is equals to summation I equal to 1 to n xi times P of x is equals to xi. So if you substitute the values, 0 times 0 plus 1 times k plus 2 times 2k plus 3 times 2k plus 4 times 3k and so on up to plus 7 times 7k square plus k. So if we simplify this we can get 366 over 100. Mu is equals to 3.66. Next question number 3, p of 0 less than x less than 5. That is p of x is equals to 1, p of x is equals to 2, p of x is equals to 3, p of x is equals to 4. So 8k we are getting already, we know k value I think. Yes, k value already we have 1 over 10, substitute 1 over 10 then we can get the answer. Right, I hope. Last question. The range of a random variable x is equals to 0, 1, 2 0, 1, comma 2. Given that x is equals to 0 is 3c cube, x is equals to 1 is 4c minus 10c square, x is equals to 2 is 5c minus 1. Then find the value of c. First question, find the value of c. Second question, p of x less than 1. Third question, p of 1 less than x less than or equal to minus 2. And the fourth question is p of 0 less than x less than or equals to 3. So given x is equals to 0, 1, 2, that is the range of yes. So summation I is equals to 1 to n, x is equals to xi is equals to 1, 1, 2, if we substitute p of x equal to 0 plus p of x equals to 1 plus p of x equal to 2 is 1. So p of x equal to 0 value 3c cube, p of x is equals to 1 value 4c minus 10c square, and p of x is equals to 2 value 5c minus 1. Simplify all, you can get 3c cube minus 10c square plus 9c minus 2. Then try to find out the values of c here with the help of the Honors method. Then if with the help of the Honors method we are getting c is equals to 1 and then c is equals to 1 over 3 and 1 over 3 and 2. So p of x less than 1 is the second question. P of x less than 1 is equals to p of x is equals to 0. P of x less than 1 they are asking. Okay, first question c calculated and p of x less than 1 they are asking. That is p of x equal to 0. It is a 3c cube only. But we have for c 3 different values. Then substitute the 3 different values, you can get the final answer. First one, 3 we are getting, it is not possible. 24 we are getting, it is not possible. 1 over 9, yeah, that is okay. Next to p of 1 less than x less than or equals to x is equals to 2, only x is equals to 5c minus 1. Again, substitute the values for 1 and 2, we cannot get the required answer, means the possibilities cannot come. So for 1 over 3 it is true. Next one is p of 0 less than x less than or equals to 3. P of x is equals to 1, p of x is equals to 2, p of x is equals to 3. Substitute the values and simplify. Okay, substituted and simplified. Minus 10c square plus 9c minus 1 we are getting. And in that if we substitute c is equals to 1 over 3, only for c is equals to 1 over 3 it is possible, sir. So substitute c is equals to 1 over 3, then we can get 8 over 9. Achha, one more question is there. Question number 8. The range of random variable x is 1 to 3 and p of x is equals to k is c power k divided by k factorial where k is 1 to 3. Find the value of c. Again same like above, find the value of c and 0 less than x less than 3. First overall sum is 1. If we add up overall sum, we are getting c to the power of 1 by 1 factorial and c to the power of 2 by 2 factorial. Here infinite sequence it is. So we can get we are getting a c to the power of 1 plus c square, right. This is e power x expansion. So e power c is equals to 2, then c is equals to log 2 to the base e. Good question. Next, p of 0 less than x less than 3, p of x is equals to 1, p of x is equals to 2. We have to calculate c plus c square by 2 from the definition. X is equals to 1 and x is equals to 2. Substitute c values. Oh, one more question. 2 dice are rolled at random. Find the probability distribution of the sum of the numbers on them. Find the mean of the random variable. Sum is given already, I think. Dice 6 faces. Dice has 6 faces. 1 to 6 numbers are written on each of the faces. 2 dice are rolled. Sample space yes consists total 36 points. 1 1 1 2 1 3 1 4 1 5 9 7 7 6 6. Let extend the sum of the numbers. Sum is possible. What 1 plus 1 1 plus 2 1 plus 3 1 plus 4 1 plus 5 and so on 6 plus 6. So these are the possible sums. So according to that we have prepared the table for 2, 3, 4, 5, 6 and so on 12. Nothing but 1 over 36, 2 over 36 and so on up to 1 over 36. And then mean of x is equals to summation x is equals to summation I is equals to 1 to n. Xi times p of x is equals to xi. Here 1 to n is nothing but 2 to 12. Then substitute all the values. Okay, write the formulas and substitute here. First x is equals to 1, x is equals to 1 by 36, x equal to 3, 2 by 36. In the way all the values we are getting here. Right, that is 7. And next question number 10. Table is given already. Probability distribution of the random variable x. And find the variance of x. Find the variance of x. Okay. So to get variance, mean is required. No, first let us calculate the mean. Summation I is equals to 1 to n xi times p of x is equals to xi. Quantity table is there, substitute everything, then mu value we got 0, then the variance will become summation I is equals to 1 to n xi square into p of x is equals to xi because mu is 0. Then simplify the values. Question number 11, x is equals to x and x is equals to x. Again same like above question. Sum of all probabilities is 1 to get k value. K we got, then mu we have to calculate. Then after that variance formula. Yes, variance formula and substitute mu value in the variance and simplify. That's it. And the last question is about the practice. If x is a random variable with probability distribution, x is equals to kk plus 1 of c by 2 or kk is equals to 1, then find c. Okay, sum of probabilities you can take, then you can get c value. In the above already we have solved. For c we have 3 values. Same model question. Okay, thank you students.